In this lesson, we are going to talk about how to represent functions and what notation are we going to use. Probably you have seen the notation which is being used previously, but we never talked about how each element of the notation meant. The way that we are going to show a function is something like f of x is equal to some function of x here. This indicates that f is our function and the independent variable, in this case x, is being used. Now, if we say that f of 2, this means evaluate the function f when x or the independent variable is equal to 2. This is read as f at 2 or f of 2. As the first example, suppose the function is f of x, or f at x is 2x minus 4. We are supposed to find f of negative 2, f of 5, and f of half. So, to find f of negative 2, I'm going to write that f of negative 2, I'm going to replace x with 2, with negative 2. So I'm going to write it as 2 open bracket negative 2 minus 4. The reason I'm using open bracket and close bracket is to conserve the bed mass. Now 2 times negative 2 is negative 4, minus 4 is negative 8. To find f of 5, I do the same thing. So I'm going to say 2 open bracket 5 minus 4, which is 10 minus 4, which is going to give me 6. And at the same time, f of 1 over 2 is 2 times 1 over 2 minus 4. 2 times 1 over 2 is going to give me 1 minus 4, which is negative 3. In the next example, we have f of x equal 3x squared minus x plus 7. We have to find the first one that we have to find is f of negative 2. So f of negative 2 is equal to 3 times negative 2 again, exponent 2, minus open bracket negative 2 plus 7. Just note the usage of open and close brackets every time that I substitute in a value. Negative 2 squared is 4. 4 times 3 is 12. Minus times minus gives me positive, so it's plus 2 plus 7. This gives me 14 plus 7 is 21. The next one that we have to find is f of 5 is 3 open bracket 5 squared minus 5 plus 7. 5 squared is 25. 3 times 25 is 75 minus 5 plus 7. If you simplify this one, you get 77. And then f of 1 over 2 is 3 times 1 over 2 squared minus 1 over 2 plus 7. 1 over 2 squared is 1 over 4 times 3 is 3 over 4 minus 1 over 2 plus 7. We can write it as 7 over 1. The common denominator is 4. Now 4 divided by 4 gives me 1, so this is 3 minus 4 divided by 2 gives me 2. 2 times 1 is 2. And 4 divided by 1 is 4 times 7 is 28. If you simplify this one, we are going to get, this one gives you 1, so the answer is 29 over 4. Another way of representing functions, beside function notation that we covered, f of x, we can use what we call a mapping notation. Now, in a mapping notation, we are going to represent using two ovals. We are going to use the domain and the range, and we are going to use arrows which goes from the domain to range, showing the relationship between the values, like the example here. For instance, this means that when x is 1, y is 1, when x is 2, y is 4, when x is 3, y is 9, and so forth. In the first example, we have been given two mapping diagrams, and we are supposed to write a set of ordered pairs and state if the relationship is a function. Now, to write it as an ordered pair, I'm going to write using a curly bracket. So I'm going to say the function is 1 comma negative 5. This is 1 point. 1 goes to negative 5. 2 goes to negative 1. 3 goes to negative 5. 4 goes to 0. 5 goes to 0. 6 goes to 5. And the last point is 7 goes to 8. This is my ordered pair. And the second part of the question says if this is a function. Now, remember the definition of a function. For every x, you have to have only one y, or one range value. If you look at your x's here, you can see that none of these points, they have two arrows coming out of one domain number. If you look, 1, there is only one arrow, 2, 1, 3, 1, and so forth. So this is a function. The next question is the same. So for ordered pair, I'm going to write open bracket, curly bracket, 2, 1, 2, 2, 5, 3, 8, 7, 11, 5, 14, 4, and 14, 6. Now the question is that, is this a function? No, because if you look at 2, there are two arrows coming out of it, and also 14, there are two arrows coming out of it. This means that for 2 and 14, there is no unique y value. So this means this is not a function, not a function. The next question says write each function in mapping notation. Very simple. For instance, for f of x equal 3x squared minus 2x plus 1, we are going to write in mapping notation as f x goes to 3x squared minus 2x plus 1. This is the mapping notation for f of x equal 3x squared minus 2x plus 1. For the next example, the same way, we are going to write p x goes to 500 minus 2x times 300 plus x. That's a mapping notation. The next example, we have been given the information about the temperature of the water. At the surface is 22 degrees Celsius. As you go down the water temperature decreases by 1.5 degrees every 8 meters. First, we are supposed to model the water temperature at any depth using function notation. Looking at the information, it is obvious that the y-intercept, or the initial temperature, is 22 degrees. The second thing, we know that the temperature decreases linearly with depth of the water. So I can write that the function t of d, remember, since it is a linear relationship, I can write that it is md plus b. Remember, d is really your x value, and t is really your y. Remember, y equal mx plus b. Since I'm using the function name t, and d is my x, then this one is really x, so you have mx plus b. Now, your y-intercept is 22. So we know that this is plus 22, because b is 22. Now we have to look to find what exactly is our slope. Remember, our slope here is rate of change, and rate of change is 1.5 degrees Celsius, but decreasing. So it's going to be negative 1.5. And also, remember that this decrease happens every 8 meters. So whatever the value of d is, we have to divide it by 8 to see how many 8 meters is inside that value. So we're going to have d over 8. So this is going to be my equation. T of d is equal to negative 1.5. Negative 1.5 because decreases by 1.5 degrees. This is the slope. 22 is our initial value, which is at the surface. And we are dividing by 8 because the decrease is every 8 meters. The next part of the problem says use this function that you found in part A to find the water temperature at a depth of 40 meters. So we are going to say T of 40 is equal to negative 1.5 times 40 divided by 8 plus 22. This is 0. And if you use your calculator and evaluate this one, you get 14.5 degrees Celsius. So at the depth of 40 meters, the temperature is 14.5 degrees Celsius. The next part of the question says at the bottom of the lake, the temperature is 5.5. How deep is the lake? Remember, the equation in part A was T of D is 22 minus d over 8 times 1.5. We know at some depth the temperature is 5.5. Now we have to find d. To isolate d, I'm going to move this whole product to the right and this one to the left. So I get 22 minus 5 is equal to d over 8 times 1.5. 22 minus 5 is 17. So I get 17 is equal to 1.5 d over 8. This is divided by 1. I cross multiply. So this gives me 17 times 8 is 1.5 d. I divide by 1.5 both sides. I get d is 17 times 8 divided by 1.5, which is approximately 88 meters.